Okay, so welcome back, and now what we're going to do is we're going to talk about Leibniz notation as it applies or as it's used with the chain rule. Now you saw this in a previous video, in a previous rule, or previous video, excuse me. And so we're repeating a little bit of this. So the rule using Leibniz notation, remember, is that we're saying y is a function of u, and also u is a function of x, and then we could write it this way, okay? Where we have dy dx, that's the derivative we're using, the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So that's what we're going to use to find the derivative of a function. So you could use Leibniz notation the same way we use function notation. So let's use this example here. So we got y is equal to this expression where we have a power function, right? This to the fifth power, and then inside we have a rational function. So now what we're going to do is we're going to apply the chain rule using Leibniz notation, because what we're going to do is we're going to define u as a function of x as x divided by 3x plus 2. And so what we're going to do is, if we want to get dy dx, that's going to equal the derivative of u, or excuse me, the derivative of y with respect to u. Well, that's going to be the derivative of y with respect to u. So we're going to have what? We're going to have y equal to u to the fifth, right? So we're going to take dy du. Okay, so that means what? Dy du is equal to what? It's going to be 5 u to the fourth. Okay? And now here for u, du dx, we're going to have to use the quotient rule, right? So du dx equals, now remember the quotient rule, low d high, so it's going to be 3x plus 2 times 1 minus high d low, okay, over low squared. And so if we simplify this, we get what? We get 3x plus 1 minus 3x, right? So we get 3x plus, excuse me, did I say 1? 3x plus 2 minus 3x. So we get 2. So we end up with 2 divided by 3x plus 2 quantity squared. So now if we apply this, dy du is 5u to the fourth times 2 over 3x plus 2 squared. Now, we can't leave the u in there because we have to have everything in terms of x. Since we started with x and we want dy dx, it's got to be the derivative of y with respect to x. So we can't have any other variables in there, so we're going to have to substitute in for u. Okay? And so we end up getting what? Well, it's going to be 5 times 2, right? The u we're going to substitute in, so it's going to be what? Excuse me. Y is this, or excuse me, u is this. So we're going to get x over 3x plus 2, oops. Right? So u is equal to this. So we're going to get this to the fourth power times, now this 5 can be multiplied with that 2, so we're going to get 10 over the quantity 3x plus 2 squared. Now, we're not done because we can multiply this together, right? We can combine this. So we've got a common factor here, so we can multiply these two together, and then we can multiply these together. Okay, because this is a fourth, so we could use the distributive property here. So let's see how this works. I'm going to do it in a couple steps. So what we're going to have is we have x. So we have x to the fourth over 3x plus 2 to the fourth times 10 over 3x plus 2 to the second, or squared. Now I can combine these two because these have the same base, so, rule of exponents, property of exponents. So I can multiply across the top, multiply across the bottom, and I get my final answer, which is going to be 10x to the fourth over the quantity 3x plus 2 raised to the sixth power. And that is our final answer. Okay, so again, let me just explain that it's important to realize that the final answer has to be in terms of the original variables. Okay, so here we have y and x. So we're looking for dy dx. So the final answer has to be in terms of x. So we can't have any u's here. So if you have any other variables, you have to back substitute and put it in terms of x. And then once you do that, you simplify it until you can't simplify it any further, and you're finished. Have a great day.